Yes, sir.
Okay. So we are going to see this waves. Waves means flow of energy. It's a kind of, it's not energy, it's the flow of energy. Without flow, wave does not have any meaning. So energy always flow from one point to another point. Or basically, if you look into the technical definition, it is a kind of disturbance which moves from one point to another point, and it carries momentum and energy wherever it goes. It carries momentum and energy with it. Now, these waves can be classified into two categories. One is called mechanical waves. Mechanical waves, and this is called non-mechanical waves. Mechanical waves and non-mechanical waves, basic difference is mechanical waves can pass through solid, liquid, and gas, but not through vacuum. Not through vacuum. It cannot pass through a space where nothing is there. So mechanical waves cannot pass through vacuum. Whereas non-mechanical waves can pass through solid, liquid, gas, and also through vacuum.
Sure. So, like mechanical waves require a medium, sir, whereas
Yes,
non.
always, it requires a
Yes, sir.
medium.
Yes, sir.
Always, medium is must. Whereas non-mechanical waves is a self-sustaining electric field and magnetic field oscillation. So that we will see in detail. Non-mechanical waves we will see in detail in class 12 under the chapter electromagnetic waves. Full detail is there, like equation, pressure, momentum, energy, all formulas. So this is not in our syllabus for class 11. Mechanical waves and non-mechanical waves, one more difference is mechanical waves are a bit slow. They have a very less speed as compared to non-mechanical waves, which moves with extremely fast speed. Even in its vacuum, they move with speed of light, which is the maximum possible speed as per our knowledge. Okay, right. Now,
Yes, sir.
example of mechanical waves are, we will learn sound waves, we will learn string waves. Other example which we will not learn, like matter waves. That matter waves we will see later on in class 12 also. Matter waves. Whereas non-mechanical waves examples are all the electromagnetic waves, especially light. Like light is an example of electromagnetic waves. Apart from these waves, earthquake waves, which is also called seismic waves, earthquake waves, which is called seismic waves. They are also example of mechanical waves. These waves are produced during earthquake and it moves with very fast speed everywhere. And by measuring these two kind of waves, seismic waves are of two types, P waves and S waves, that we will see later on. By measuring these two waves, we can exactly calculate where is the epicenter of the earthquake, means where is the originate, which is the originating point. Okay. Now, okay, first you write down, then we will discuss about. So we are not going to discuss about this. We are going to discuss about mechanical waves. Yeah. Please note it down. And then we will look into this.
Sir, what have you written, sir, after the string waves?
Matter waves.
Matter. Okay, sir.
I need to.
Completed.
Okay. Now, so about mechanical waves, they can be further classified into two categories: longitudinal waves and transverse waves. I think you know about these two waves. I am in grade 8 and 9, we do have this one. Any idea?
Sir, no, sir.
Of blank mind?
Yes, sir.
Okay. So longitudinal waves means if the wave is going like this, if the wave is going like this, since we are talking about mechanical waves, so medium must be there. And medium has particles. So there may be a possibility that wave is moving like this. Wave is energy which is invisible, but its effect will be shown by the particles. Okay. So let's say when it moves, the particle through which it is moving, they start doing oscillation like this. They start doing oscillation like this. Means wave is moving along this direction and oscillation is also along this direction. This type of waves are called longitudinal waves. Okay. Examples: sound waves. Sound waves are longitudinal waves. Okay. Then we have P waves, that P seismic waves, P waves, etc. They are longitudinal waves. Whereas there are certain kind of waves, when they move, the particles, they start oscillating perpendicular to the direction of the propagation of wave. So they will start oscillating perpendicular to the direction of propagation of wave, like this, like this. Okay. So, okay. So this kind of wave is called transverse wave. Example is string waves and also that S waves of seismic waves. Okay. These are the transverse waves. So please write it down. Here P refers to primary waves, and S refers to secondary waves. We will see this later on in detail. Done?
1 minute. Done, sir.
Okay. So now let us look into equation of mechanical waves. Equation of mechanical waves. So we know that, let's say this is the origin of the wave or source of the wave. So so the wave is moving like this. We know that when wave flows, then particles will start oscillating. So for the time being, let us take the transverse displacement. So the particle is oscillating like this. When the wave, so a wave is flowing like this, particle is oscillating like this. So this is wave and this is particle displacement. Now we are concerned about a particular we are concerned about a particle which is at a distance of x. So let's say it is moving along x-axis. So it is moving along x-axis. So we want to find the instantaneous displacement of a particle which is at a distance of x from the origin at time t. So let's say at a distance of x, we choose one particle, and that particle at any time t, let's say particle is making one y displacement. This entire thing can be written as yxt, that is particle instantaneous displacement at a distance x at time t is given by a sine omega t plus minus kx plus phi naught. What are these? So here a means amplitude. Amplitude is the maximum distance. It is the maximum distance of the particle from the mean position. So it is the maximum displacement of the particle from mean position. Mean position. What is omega? Omega is angular frequency. Omega is uh, angular frequency, which is equal to 2 pi f, which is equal to 2 pi by t, where f is the linear frequency and t is the time period. Linear frequency and t is the time period. And k is called angular wave number. Angular wave number, which is equal to 2 pi by lambda, where lambda is the wavelength. And phi naught is called initial phase, or it is known as epoch. It is the initial status of the wave at time t is equal to 0, at x is equal to 0. Okay, so please write it down. This is the all these information we get from mechanical from the equation of the mechanical waves.
Completed, sir.
Done?
Yes, sir.
Good. Now, there is something more. There are some more information that we can get from this. Let us look into this. So, information are this. Whatever variable is attached with x, with k, that will give you the direction of wave. For example, kx means wave is moving along x-axis. Ky, wave is moving along y-axis. This does not matter, okay? Only the variable which is attached with k. So kz means z-axis, wave motion. Wave is moving along this. Then this is the one information. Another information is if sine of omega t and kx are same, if sine of omega t and kx are same, then wave is moving along negative axis. Whether it is, okay, yeah, I'm writing x here, na? So negative x-axis. Negative x-axis. Had it been y, so you have to write negative y-axis. If sine of omega t and kx are opposite, sine, they are opposite, then wave is moving along positive x-axis. Please write it down. Then we'll see some example.
Completed.
Okay. Mm, okay. So now, one more thing. From this definition, you can also get the speed of wave. So speed of wave is given by omega by k. That is omega is 2 pi f, k is 2 pi by lambda. That is f lambda. We know this. This is the speed of wave. Okay. So. Write it down and then we'll see some questions. Shall I erase this one?
1 minute, sir.
1 minute. When we had decided to start our class 12 syllabus?
26th of February, sir.
Yes.
Yes, sir. Sir, I have completed it, sir.
Okay, now questions. So question is, equation of a wave is given by 20 sine 100 pi t minus 50 pi x plus 45 degree. All units are in SI. Find amplitude, angular frequency, linear frequency, time period, wavelength, speed of wave, direction of wave, initial phase. Yeah, that's it. All units must be in SI.
So time period is equal to omega t, right, sir?
Tell me once again.
Time period is equal to omega t, right, sir? Sorry, omega 3 t plus initial phase, right, sir?
Time period.
Yes, sir. Omega t plus epoch.
Why? No, no, no,
Ome
no. Just see. Oh,
omega t,
okay.
sir.
Wait. Hold a minute. Okay, tell me what is the answer for this amplitude?
20, sir.
20 meter.
Okay,
Angular
sir.
frequency. What is angular frequency?
Sir, I have to say it in SI, sir.
Angular frequency is 100 pi. Whatever is there, this is angular frequency. 100 pi radian per second. Okay. What is the
Yes, sir.
linear frequency? Linear frequency will be 100 pi is equal to 2 pi f. So pi cancel. This is 50. So linear frequency is 50 hertz. Time period is 1 by frequency. That is 1 by 50 seconds. That is 0.02 seconds. Okay. Have you got it?
Yes, sir.
Then why you are complicating the things? Okay. Then wavelength. Okay. Do this four.
Yes, sir. I got the direction of wave negative x-axis, sir.
Obviously, you got the wrong one. What I told you, if sine of omega t and kx are same, then it will be negative. But here it is positive, right? Opposite sign. Can you please go into the notes and see what
Yes, sir.
what will be direction if sine of omega t and kx are opposite? Can you just check it? Hello.
Yes, sir. 1 minute, sir.
Huh.
So positive, sir.
Yeah, it is written or not? Tell me first.
Yes, sir.
Then why are telling me negative? Says it is positive x-axis. Then rest, find out wavelength.
Yes, sir. Sir, for wavelength, I should know the speed, right, sir?
Means you are not listening to me what I am writing, huh? Okay. What is the angular wavelength?
Angular wavelength, sir, minus 55.
Not minus, Baba.
Sorry, 55, 55, sir.
50 pi. Okay. So k is equal to 50 pi. But k is equal to 2 pi by lambda. So 2 pi by lambda is equal to 50 pi. So lambda is equal to 2 pi by 50 pi. How much you are getting? Pi cancel. It is 25. 1 over 25 meter. That is 4 centimeter.
Yes, sir.
Now what is omega? Okay. Now what is the speed? For speed, omega by k directly put. Omega is 100 pi, k is 50 pi. So 2 meter per second. Is it okay?
Yes, sir.
You please follow whatever formula I am giving you. Try to use that one. Life will be easy for you. So while calculating the speed of wave, you can directly write omega by k just by looking at this. This is omega, this is k. That's it. And what is the initial phase? 45 degree.
45 degree.
Hopefully you have understood this.
Yes, sir.
Good. Now,
1 minute, sir.
yes.
Noted, sir.
Okay. So, just one. Hmm, just 1 minute. Huh? Uh, okay. Now, so what we have seen is y displacement is equal to a sine omega t. Let us take the wave to move towards positive x-axis. So we can write like this. So the graph, so it will be something like this. This graph will go like this. Now we want to find the velocity of the particle, not the wave velocity. Particle of the velocity, velocity of the particle, which is doing SHM when the wave is flowing through it. So particle velocity is given by differentiation of y with respect to time. So that means we are differentiating this entire thing. So using the chain rule, we will get a omega cos omega t minus kx. So we can see that this is a omega sine omega t minus kx plus pi by 2. So particle velocity leads displacement of the particle by pi by 2. So that means if this is y and if we have to draw the graph of VP, so VP will be one step ahead. It will go like this. Amplitude may not be equal. velocity peak will be different, but their difference will be this one, t by 4. So this is the velocity which is going like this. Now, if you want to calculate the acceleration of the particle, so we have to differentiate it once again. So if you differentiate, we will get minus a omega, okay, minus a omega squared sine omega t minus kx, right? So it means that this is equal to a omega square sine omega t minus kx plus pi. It means that acceleration of the particle leads velocity of the particle by pi by 2, or we can say that acceleration of the particle leads the displacement. So leads displacement of the particle by pi. So if you draw this graph, it will be totally, remember, acceleration graph will be exactly opposite to y graph. So y is this one. So our this one will be just mirror image of this. This green color graph is for acceleration of the particle. These three graphs are similar to SHM also. If one particle is doing SHM, then their speed, displacement, and acceleration, their graph is shown like this only. Okay, so please note it down.
So for displacement A sine omega t minus kx, and then initial phase should come, right, sir?
Mm,
Plus omega t minus kx plus pi naught, sir? Or how is it different from the previous one, sir?
which one? Which one?
The first one, sir, y is equal to a sine omega t minus kx plus pi naught should come, sir. The top one.
Can you please show me by marking? I'm
Yes, sir.
unable to understand.
So this one, sir, plus pi naught should come, sir, or how is it different from the previous one, sir?
Previous one means?
Like previous one, you wrote the equation as a sine omega t plus or minus kx plus
Oh, that
pi
I was
naught.
saying that was the general equation. But now I'm telling you that wave is moving along positive x-axis.
Yes, sir.
So
After that, the initial phase, sir.
initial phase 0. That means it will start with this
Okay,
point.
okay, so that was what I was asking, sir.
Okay. Yes. Yes.
Completed, sir.
Okay. Now, so. Okay. So now this is done. Okay. Now phenomena related to waves. Let me write here. Wave phenomena. So let us talk about this wave phenomena. Hmm, okay. There are various wave phenomena that we are going to study. Like we will see reflection, refraction, just equation wise we will see refraction or transmission basically we will see. In more detail, we need to look into interference. Diffraction we will not see. We will see standing waves, and then Doppler effect. This we will see. Doppler effect, by the way, this time it was not in NEET, but still we will do it. So reflection, transmission, interference, standing waves, and Doppler effect. And also the last one is last one I have to write beat formation.
Yes, sir.
Okay. So this one. Mm, Okay. Now let us start with the. We can start with interference. It is a big topic. Then we will go to standing waves and then Doppler effect. So let's see this interference. Whatever you are learning here, these are similar to wave optics in class 12. So it will help you. Why my handwriting is not good? Inter. Maybe I'm trying to write very fast. Interference. Okay. So whatever we are looking at, the same concepts will be used as it is in wave optics in class 12. Okay. So when two waves moves in same direction, then they will interfere. Then they will interfere. That means they will interact at a point to produce a kind of phenomena called interference. Here we will see two kind of interference. One is called constructive interference. Constructive interference. Another is called destructive interference. Destructive interference. Okay. So we will look into this. Hmm. Just. Uh, okay. So S1 and S2. So let's say there are two sources of wave, S1 and S2. And these two sources are coherent sources. Coherent sources means basically they should have the same frequency. So they are emitting waves of same frequency and they are hitting a particle which is at a distance of x1 from first source and x2 from the second source. Now when when only S1 was active. Imagine that S2 is not there. So the particle movement is given by under the effect of S1 wave is A1 sine omega t minus kx1, let's say. And when only S2 was there, assume that S1 was not there. So under the effect of S2 wave, let's say its displacement is A2 sine omega t minus kx2. Now, when these two waves are activated together, that is simultaneously, then the particle displacement is just the sum of the two individual instantaneous displacement. Now, there is some maths involved, but that detail of maths is not important. What is important is when we do this, when we add these two, we will get something net amplitude sine of something. This is also not required what you will get. Important is this net amplitude because intensity, net intensity at any point is directly proportional to square of amplitude. So we will see that how intensity varies at a particular point when the two waves interfere at a point. So henceforth we will see what are the different kind of what may be the minimum and maximum a net possible, and then in which circumstances we are getting constructive and in which circumstances we are getting destructive. Okay.
Sir, A net is what, sir? And net amplitude or
A matrix. Where is a matrix?
no, sir, A net.
A net is net amplitude,
Yes, sir.
and intensity is directly proportional to a square. So after this, we will see something more. You just write it down. So we will see that what is this net amplitude, which value it can take. We will see that those things. Done?
Yes, sir.
Okay.
Yes, sir.
D. Okay. So now this net amplitude, we will look into this net amplitude. Net amplitude is mathematically given by A1 square plus A2 square plus 2A1 A2 cos phi. What is this phi? So A1 A2 is the individual amplitude. But what is phi? So phi is called phase difference between the two waves. Phase difference between the two waves. We know that phase of one was omega t minus kx1 and phase of other one was omega t minus kx2. So if you remove the bracket, you will get kx2 minus x1. You see? So that means k delta x, k is 2 pi by lambda. So phi is equal to basically phase delta phi. Okay, let it be fine. So phi is equal to 2 pi by lambda delta x. This is the relation. This is very, very important. Very important. It will be used in class 12 also. It gives us relation between phase difference and path difference. Sorry, here, let me write here. Delta x is the path difference. So this is important. You write it down.
Yes, sir. 2 minutes, sir.
Okay.
Completed, sir.
Okay. So now, depending upon this phase and part difference, we have to write about the constructive and destructive interference. Okay. So let's do it next time. Uh, Whenever you are at home, let me know. Do you have any holiday within this week?
No, sir, because from Saturday my exam will start. But I have holidays from the 25th to 1st March, sir. That is like our 11th to 12th transition, so they give holidays for us. I'll just confirm the dates and send in the group, sir. I'm not sure
Please,
about this.
please, please, because I have to adjust accordingly. So it will be
Yes, sir.
good if we can get like continuous 10 to 12 classes. We will finish most of the things. Our target is 26th. Before 26th, I need to take about 6 to 7 classes, 7 hours.
Yes,
So
sir.
you I'm just asking you about 7 hours from your 24 into what 10. So 240 hours. I'm asking only 7 hours. Is it too
Yes, sir.
big?
No, sir.
So I'm not asking anything, right? So 7 hours. I'm asking you from 240 hours. Okay. So yeah, let me know. 7 hours extra than our usual classes.
Yes, sir. I'll say the timing, sir.
Okay. Okay then. So good. Please
Sir,
revise everything. Tell me.
sir, my exams only starts at 15th. So like 13, tomorrow also we can have classes if you're free, sir.
Tomorrow, right?
Yes,
Just
sir. Tomorrow
1 minute. So
after 6, sir, because I'll come
just
from
one
school
minute.
after 6.
Tomorrow after 6, right? Tomorrow
Yes, sir.
after 6. So, we can do. I think we can do. I'll let you know at after 6. So 9 o'clock. This 9 o'clock, I will be free. I'll let you know. You
Yes, sir.
you will be there, right?
Yes, sir. After 6, I'm free, sir. After
Okay, okay.
6.
I'll let you know by tonight itself. I will let you know.
Yes, sir.
Hmm? Okay,
Yes.
okay then. Please revise everything whatever we discussed.
Okay, sir.
Okay then. Okay then. Bye bye. Yeah.
Thank you, sir. Bye, sir.